There is a vehicle on the road right now that has been rotating continuously for the last 40 minutes. Not the wheels, not the engine. The entire barrel mounted on its back has been turning, slowly and without stopping, since it left the plant on the edge of town. It will keep turning through traffic lights, through highway on-ramps, through the narrow streets of a construction site, and it will not stop until the material inside has been poured. That barrel is not decorating the truck. It is not a logo. It is doing something so specific and so strange that once you understand it, you will never look at a construction site the same way again. So here is the question. Why does it never stop? Most people who think about this at all land on the same answer. The spinning keeps the concrete from settling. They picture the heavy aggregate, or the sand, the gravel sinking to the bottom of the drum while the water floats up, and the rotation as a kind of stirring mechanism that keeps everything mixed together. That explanation feels right. It has the shape of correct things. Gravity pulls stuff down. Rotation fights gravity. Problem solved. The logic is satisfying in exactly the way a wrong answer often is. Here is the part nobody prepares you for. Concrete does not harden because of gravity. Gravity does not care about your pour schedule. Concrete hardens because of a chemical reaction called hydration, and once you add water to cement powder, that reaction has already begun. It is counting down whether the drum spins or not. You have, on a normal mix and in normal temperatures, somewhere between 90 minutes and 2 hours before the material becomes unworkable. That is less time than a typical feature film. It is less time than many traffic jams. A fully loaded cement truck is not carrying a liquid waiting to become solid. It is carrying a solid in the middle of becoming itself, and the clock started the moment water touched powder. This is what nobody tells you about concrete. The spinning is not about mixing. The spinning is about buying time inside a reaction that cannot be paused. When the drum rotates forward, the internal blades push the mix toward the back, folding it over on itself continuously. That constant folding does two things simultaneously. It disrupts the microscopic crystals, called calcium silicate hydrate crystals, that are beginning to form and interlock as the hydration reaction proceeds. And it keeps the mix homogeneous, not because gravity would otherwise separate it, but because without agitation, the chemical reaction proceeds unevenly, creating pockets of material at different stages of hardening inside the same drum. The spinning is not a preservative. It is a controlled interference. Every rotation is a tiny act of structural sabotage against the chemistry happening inside. The numbers here are worth sitting with. A standard transit mixer, which is the proper name for what everyone calls a cement truck, carries between 6 and 10 cubic meters of concrete. 10 cubic meters is roughly the volume of 4 large family cars crushed into a single mass. That material weighs somewhere around 24,000 kilograms, which is about the weight of 3 adult African elephants. That weight is rotating on the back of the truck right now, on a public road. At roughly 1.5 revolutions per minute during transport, and the system has been engineered specifically so that the center of gravity of that rotating mass sits as low and as centered as possible. If it did not, the truck would become dynamically unstable on curves at ordinary highway speeds. The engineers who designed this were not building a mixer. They were solving a ballistics problem with a 40-minute deadline. The reason the system exists exactly as it does today traces back to a problem that was not, initially, an engineering problem at all. It was a logistics problem, and it almost killed the ready-mix concrete industry before that industry had a name. In the early 20th century, concrete was mixed on-site. Workers combined cement, aggregate, and water at the construction location using hand tools or small mechanical mixers. This was slow, inconsistent, and dependent on the skill of laborers who had wildly different ideas about the correct ratio of ingredients. In 1926, an engineer named Stephen Stepanian applied for a patent on a self-discharging motorized transit mixer. The concept was simple. mix at a central plant where quality can be controlled, then transport to site. The problem was that nobody could figure out how to transport it without it setting in transit. Early attempts used sealed drums with no agitation. The concrete arrived in various states of partial hardening that made it unusable, or it arrived as a solid mass that had to be broken out with jackhammers. The rotating drum with internal helical blades was not invented all at once. It was converged upon over roughly 30 years of failed attempts, patent disputes, and poured concrete that had to be discarded by the truckload. The geometry of those internal blades, the pitch of the helix, the ratio of drum diameter to length, these are not arbitrary. They are the accumulated scar tissue of 3 decades of expensive mistakes. Once you see the principle, you see it everywhere, and you realize you have been seeing it without knowing. The agitation tanks used in pharmaceutical manufacturing keep suspensions from separating the same way the drum does. The paint you shake before opening is undergoing the same fight against settling chemistry. Soft-serve ice cream machines rotate their mix continuously because the fat crystals in dairy cream behave like the calcium crystals in cement. As they begin to organize structurally the moment temperature drops, and rotation disrupts that organization. The tumble in a clothes dryer is not primarily about heat distribution, it is about preventing fibers from matting and bonding while wet. A bartender stirring a cocktail that contains egg or cream is not just cooling it. The agitation prevents the proteins from beginning to denature unevenly. Bread dough rested in a proofing drawer is occasionally folded, not to mix it further, but to equalize the carbon dioxide produced by fermentation across the mass. Every one of these is the same operation, a timed chemical process being managed by mechanical interference. The honest problem with this system is that the clock is absolute and the road is not. Heat accelerates the hydration reaction, which means a cement truck sitting in summer traffic in a city like Phoenix or Mumbai is losing workable time faster than the driver knows. Most specifications require that concrete be placed within 90 minutes of water contact or before the drum has made 300 revolutions, whichever comes first. In practice, traffic delays mean that a meaningful percentage of all concrete loads arrive at the edge of usability or past it. The industry response has been to add chemical retarders to the mix, compounds that slow hydration and extend the window. But retarders change the final mechanical properties of the concrete. The compressive strength, the porosity, the long-term durability of the material are all affected by the chemistry used to buy 30 extra minutes in traffic. Some of the concrete holding up the buildings around you was almost too late. That is not a scandal. It is just physics negotiating with infrastructure, and physics wins every time. And if you think the chemistry of concrete is fascinating, wait until you find out why the cables on suspension bridges are not made of solid steel rods, but of thousands of individual wires thinner than a pencil.